We're talking logarithmic functions in this section, you guys. The goal, there are several goals. We want to, first of all, evaluate log functions, logarithmic functions, to graph logarithmic functions, to convert between forms. There's something called an exponential and logarithmic form, and to use logarithmic functions in applications. So part of I think the scary part about math, well, one of the scary parts is all the jargon, right? The word logarithm was invented by somebody who, they wanted to scare you, whoever invented that.
Lawyers keeping their job security.
Yeah, exactly, yeah. So a logarithm is an exponent. Well, that doesn't seem as scary, does it, when you put it that way? Well, maybe it does. But exponent is cool because it has the x in it, right? Any word with x in it is cool. No? Come on, exponent is not as scary as the word logarithm, right? So a logarithm is an exponent. So take, for instance, the true statement, 2 cubed is equal to 8. Hopefully everybody agrees with this statement, right? 2 to the third power equals 8. So what's the exponent there? 3. So in a certain context, we will call that 3 a logarithm. It happens when you think of this statement from the exponent's perspective. Normally you say 2 to the third power equals 8, right? But when we think of the 3 as being a logarithm, that exponent is being called a logarithm, we look at the statement from the exponent's perspective. So if I wanted to write this statement using just regular words, from the exponent's perspective, I would say this. I would say 3 is the exponent on base 2 that produces 8. It's a long way of saying the same thing, right? 3 is the exponent on base 2 that produces 8. It's the same thing as saying 2 cubed equals 8, isn't it? 2 to the third power equals 8. But we're saying it from the exponent's perspective now. 3 is the exponent on base 2 that produces 8. Would everybody agree it's equivalent? Okay. So when we look at it from the exponent's perspective, we replace this word with logarithm. So cross out exponent, replace that with logarithm. 3 is the logarithm on base 2 that produces 8. Okay. So that's kind of awkward. We need some notation, because that's what we do in math, right? We put everything in terms of notation. So I think the 3, if we change this to so we want to put this whole statement, we want to develop some new notation for this whole statement. So the notation, well, I think we can keep the 3 the same, right? And what does is usually translate to? Equals. So 3 equals, what's the way that makes sense to shorten the word logarithm? Log. Instead of saying on base 2, let's just make the base 2 a subscript. So let's make it a subscript, log subscript 2, log base 2. That produces 8. Well, the only important thing in there is 8. So let's just drop all the rest and say 8. So the shorthand way of saying that would be 3 equals log base 2 of 8. Okay, so we would say 3 equals log base 2 of 8. Now, it's very important you don't misinterpret this notation. What a lot of students do is they think of this as 2 to the 8th power. That is totally wrong. But I'll bet some of you have done that in the past, right? You think of this as 2 to the 8th power. No, it's going to turn out the logarithm is a function. So it's going to turn out that if you want to, you can put in parentheses here so that you can remember it. It's going to turn out that 8 is the input of the log base 2 function. 3 is the output in this case. So when we start talking about logs in terms of functions, that'll help with that context, I think. 3 equals log base 2 of 8. Log base 2 is the name of the function. It's just like saying f of 8. But in this case, f, the name of f, the name of the function is log base 2. So don't think of that as 2 to the 8th power. Because do you see 2 to the 8th power anywhere in the original construct? No. It's 2 cubed equals 8. Okay, so long story short, with this particular example, we can make this statement. We can say then that 2 cubed equals 8 is equivalent to 3 equals log base 2 of 8. These are two different notations. The parentheses around the 8 are optional. Two different notations for saying the same thing. We could use kind of a double arrow statement, and that means equivalent. When you see that double arrow, it means equivalent. You'll also see if and only if, which means exactly the same thing as the equivalent statement. IFF is shorthand for if and only if. So you might see it written different ways. So we're saying that 2 cubed equals 8 is equivalent to saying 3 equals log base 2 of 8. Well, if you remember the original way we wrote that out longhand, from the exponent's perspective, it makes sense, right? When you look at this statement and you say it the long way, you say 3 is, okay, a logarithm is the exponent, so the exponent on base 2, that produces 8. That's exactly what this is saying from the base perspective, 2 in this case, instead of the exponent perspective. 2 cubed equals 8, we naturally call that the exponential form of the statement. Exponential form. And we call 3 equals log base 2 of 8, we call that the logarithmic form. Normally I shorten that to just log form. So two different ways of saying the same thing. So right now you're thinking, well, why do we need another way of saying it? That's kind of confusing. Why do that to me? Are you trying to irritate me is what you're thinking? No, there's a good reason for it. And it'll become very apparent when we start solving exponential equations. Okay? You can do things in log form. The short reason is this. You can do things in log form symbolically that you cannot do in exponential form. Specifically allows you to solve certain kinds of exponential equations. Okay, so if you generalize this idea, so the general exponential form might be something like this, a to the y equals x. So that's kind of the generic exponential form. It's a base a. A to the y equals x. Okay, let's see if we can do for this what we just did for 2 cubed equals 8. Okay, if you think about the 2 cubed equals 8 statement, what went by itself on one side when we turned it into log form? What went by itself? The exponent of 3. When you change it to logarithmic form, the exponent goes by itself. So a to the y equals x, what should go by itself? Y. Okay, and then you use log, right? So equals log. What's the base of the exponent? The base of the exponent is a, and then that becomes, that's like the 2 in the last statement, 2 cubed equals 8. That becomes the subscript or base of the logarithm. And it's a subscript. Think of it as a subscript, okay? Not a base of an exponent or anything. And then what's the only thing left? X. So x becomes the input of the logarithm. If you think of the logarithm as a function, which we are going to do. You can put parentheses here if you want, but they're optional. So y equals log base a of x is equivalent to a to the y equals x. That would be, so y equals log base a of x is the logarithmic form. And what you need to be good at is converting between exponential form and logarithmic form. Couple of restrictions here. It's not going to be useful if a and x are not bigger than 0. So first of all, if a is less than 0, then if y the exponent turns out to be a natural number, then a to the y will change signs depending on if the exponent's even or odd. If a is negative, so we don't allow that because that's confusing. So we don't allow a to be negative. Also, there's no way x could be There's no way if a is not negative, there's no way x could be less than 0 or even equal to 0 if a is bigger than 0. So x is also going to be bigger than 0. And also, wouldn't it be lame if a were equal to 1? Because then you'd have 1 to the y power. And isn't that just 1 normally? Yeah. So we don't allow those restrictions. Okay? So you're never going to have an input here in the log form that's a negative. You're never going to take the log of a negative number. Never, ever. So I call this the definition of logarithm, but really it's the definition in terms of how you convert from log form or exponential form to log form or vice versa.